Okay, lesson 57. This is probability. So, probability is a measure of how likely it is that an event will occur. You can think about the probability of whether it's going to rain tomorrow. You can think about the probability of, I don't know, you winning $1,000,000. So, you can think about the probability of me doing a cartwheel, which I'll tell you is about 0. You can think about it in terms of as it's certain to happen. So in Florida, a lot of days you're getting close to probability of 1. It's about to rain. Not going to happen. Probability is 0. In July, in Florida, I would say the probability of snow is probably close to 0 or impossible. So it goes from 0 to 1. Most of the time it's somewhere in the middle. So impossible is 0, certain to happen, absolutely certain, no chance that it won't happen. Here is 1. Most things are in between. So a 50-50 chance, it may happen, it may not, exactly in the middle. If it's less than half, it's unlikely to happen. More than half, it's likely to happen. Okay, and they also, you hear a lot of times about a chance of rain. So that's a probability expressed as a percent. Ooh, hold on, dogs. Okay, so a chance of rain. So usually that's expressed as a percent. So if it might rain tomorrow, but it's not too likely, you might have a 20% chance of rain. If you look at the weatherman's forecast and it says you have a 90% chance of rain, you're probably almost sure you're going to get some rain. So chance is expressed as percent, probability is expressed as a fraction or a number between 0 and 1. Okay, so example 1 says a standard dot cube is rolled once. So it's just a dice or a die. One of these is a die. So I have a pair of dice. And it says which word describes each event, certain, likely, unlikely, or impossible. So I'm going to slide this over so we can look at our chart here. And I've drawn some die. If I look at this, I see that those are my options on top. So I have a 1, a 2, a 3, a 4, a 5, or a 6. So there's 6 sides and 6 numbers. Each side has a separate number, right? Separate number of dots. So A says, what's the word that best describes the chance of this stopping with a 3 on the top? So what are my possibilities? I have 6 possibilities if I roll this, right? There's, oh, I got it. A 2, a 3, another 3. This must be a weighted dice. Let's try another one. 4, a 1. So, the chance that it will stop with 3 dots on the top should be 1 out of 6, right? So if I look at 1 out of 6, is that less than a half or greater than a half? It's kind of over here, isn't it? Less than a half. So it's pretty unlikely that I would get 3 on the top. What about 2 dots on the top? Oh, with more than 2 dots, sorry. So, how many chances do I have to get a number that's more than 2? 1, 2, 3, 4, right? So 4 out of 6. Looking at my chart again, is that greater than a half? Yes, so it's likely when I roll that I'm going to get a number with more than 2 dots on top. Okay, let me write that in because I didn't write that correctly. C says fewer than 7 dots. Well, they all have fewer than 7. So if I roll it, I'm definitely going to get one that has fewer than 7. So what's the probability? It's certain. There's no chance I can get a number that has more than 7 dots. What about if it has more than 6? I can't because it doesn't have any that have more than 6. So is that certain or is it impossible? It's impossible, isn't it? Can't do it because there aren't any of those that exist. So certain and impossible are pretty easy. The ones in the middle are a little trickier. So for those, what you want to do is think of all the possibilities, and that's your denominator, and think of what they're asking for. This one was more than 2. So there's more than 2, more than 2, more than 2, more than 2. So I have 4 chances to get a cube more than 2. Here they ask for 3. I've only got 1 out of 6. And then I look at my fraction to see if it's greater or less than a half. Example 2 says the circle below is divided into 5 equal size sectors. Well, you see how I draw circles. Those are not equal size, but they're supposed to be. Pretend. Each sector is labeled by one of these letters, A, B, or C. Suppose the spinner is spun and stops in one of the sectors. Okay? So if I spin it, let's say it stops on A. What's the probability of it stopping on A? So if these are all equal size, how many sectors do I have? I have 5, right? And how many of these sectors are marked A? 1/5, right? So the probability it's going to stop on A is 1/5, or 1 out of 5 chances. What about B? And that should be the same size. So how many possibilities do I have? How many possible outcomes? 5. 2, 3, 4, 5. And chances for B? 1/5. Okay, what about C? Still 5. That's my denominator. I've got 3 chances for it to stop on C. So look at that. The probability of it stopping on C is 3/5. So if I spun that spinner, it's likely going to stop on C. That's more than a half, isn't it? So if I notice 1/5 plus another 1/5 is 2/5 plus 3/5 equals 5/5, doesn't it? And that equals 1. So the probabilities of an outcome, so of all the outcomes, is always 1 if I add them up. Example 3, we're drawing marbles. Okay, a bag contains 5 red marbles, 3 blue marbles, 2 yellow marbles. Suppose we pick a marble from the bag without looking. Find the probability that the marble is blue. So how many chances do I have? I have 5, 6, 7, 8, 9, 10. So I have 10 total marbles. How many are blue? 3. So the probability that it is blue is 3 out of 10. Right? So if I drew 10 times, I would probably get a blue one 3 times. Since there are more red marbles, I'd have a better chance of getting a red one, wouldn't I? So what's the probability that the marble is not blue? So it's either red or yellow. I still have 10 chances. 5 plus 2 is 7, and then that adds up to 10/10 is 1. So I know that the possibilities are that it is either blue or not blue. Blue, I have a 3/10 chance. Not blue, I have a 7/10 chance. Okay. Example 4, Ben spun a spinner 60 times and recorded the outcomes shown in the table below. Refer to the table to answer the questions that follow. Okay, so it's important to remember that he spun it 60 times. So that's how our possible outcomes, right? He has, I'm just going to, I cannot draw circles. So here are my spinners. It says, which of these spinners most likely represents the spinner that Ben used? Let's look at what our table says. Sector 1, he got that one 29 times. Almost half of the spins were in Sector 1. Sector 2, he got 20 times, so not as much as Sector 1, not as big as Sector 1. And Sector 3 was only half of Sector 2. So I know it's not this, because surely he would, out of 60 times, he would have gotten some 4s. So let's rule that one out. these are all equal size sectors, aren't they? So you would expect those numbers would be pretty much equal. What about this one? Sector 1 is half or twice as big as 2 and 3. That was a possibility, isn't it? Because this 1 is half of the whole times that he spun, and that's half of the surface area. So that's a possibility. But then look, 2 and 3 are equal, so you would expect those to be equal. Let's look at D. 1 is half, so that's half. 2 is bigger than 3, and 2, you got 2 more often than you did 3. So it's D, spinner D. Well, if Ben spins the spinner 10 more times, about how many more times is the spinner likely to stop in sector 1? So it seems to stop in sector 1 about half the time, right? So if he spun it 10 times, you get sector 1 half of those, so you get 5 times. Probability is fun to play around with. It's something new, so some of this is kind of hard to wrap your head around a little bit at first. It's not hard stuff, but don't let it confuse you. If you get stuck on it, ask for help. Okay, good luck.